Is my screen visible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes,
Think
sir.
about this person A. Okay, in the left side, she wants to send certain amount of money, right, to person B. Okay, am I audible clearly?
Yes, sir. Yes, sir.
Yes, sir.
So what happens here? That amount of money is logged with her, right? So that amount of money is logged with her. So this is his part of her part of locking. So that money is logged with her. Nobody can take it out. Now she wants to send this money to this person, right? What happens here? This person's private key, right? Private key, just imagine itself as your password, some password, right? Which is only known to you. From his password, he has generated certain public key. From public key, one address will be generated. So when this person A wants to send certain, let's say one Bitcoin or let's say $1,000 to person B, what will happen? She will put that address, right? So like we send email, right? From my email to another email, it is something like that, that address, right? Obviously here there is no email or something like that. That is a random number, right? Alpha numerical kind of combination, right? Alphabets and numbers. So this person attaches that address, right? So what I'm telling, I have this amount of money. I want to send some part of money to this person B. So person B, I do not know, but that address is known. That address will be in that transaction. So person A is sending that money to person B's address. Okay. Now how to verify that this money belongs to this person, right? So to verify that, what she will do, she will open this. This is a closed account, right? So she will open this lock, right, with her private key, right? Before any transaction happens, right? I have to verify that yes, I have actually that money is in my account, and I am verifying that I'm sending that to other person. Otherwise, the minors can play foul. Minors can take. So these all accounts are open, right? They can take money from any other account, right? That cannot happen. So that's why private key is very important. Private key is like a password. Like if somebody knows our password to our Gmail or institute email ID, right? They can know all our email, like whatever communication has happened. Same thing here. So your private key is secured with you, right? With your private key, you will open this box. I'm just giving a simple example, like here it is shown. So she will open this box. She will put this lock. So this lock is nothing but the address of a this person B, right? Now this will go to this person B, right? What does a miner do? Miner is a miners, like those people who verify transactions. So they will verify that yes, this signature belongs to this person, right? Yes, this is a valid transaction. She is sending this money to person B, and this address belongs to this person, right? So these are the two verifications they will do, right? And they cannot change anything here. So right now, let's say she is sending this dollar is $10 or 1 Bitcoin. Miner cannot change this denomination. They cannot change 1 to 0.5 or 1 to 10. Neither they can change this address also. Let's say I am a like a evil miner and I want that 10 Bitcoin to come to me. So what should I do? Rather than putting this address of this person B, can I modify this box and put my address, right? In that case, what will happen? This money will come back to me, right? It cannot happen. Once I do that, this transaction will get invalid, right? So that is the security feature. This box is locked in such a way that none of only this person can unlock and send this money. Once she has unlocked and send this money, only this person can unlock it with his key. Why? So because this address which is generated from the public key of this person, and the public key is from the private key generated from the private key, right? So money is sent to, or transaction is being sent to an address of a person. That address is nothing but a number which is generated from the public key. Public key is again generated from a private key. So there is a two-stage security, right? That's why it is very difficult. So when I say, I will not say it is impossible. It is difficult with the computing power the miners will have. They will not able to hack into in the system where they can know that who is that person or do certain modifications, right? So here again, I'm just talking about the transaction part. We are not getting into the block part. One person sending money to another person like that. many transactions would be happening at any given moment of time. So in block, what happens? Combination of transactions gets into a block, right? So that is the link between transactions and a block, right? So like I said, private key, you will have a private key that will give you a public key. From public key, Bitcoin addresses will be generated. Reverse cannot be done. When I say cannot be done, again, it is very difficult, right? So if somebody knows your Bitcoin address, right, they cannot decipher or decrypt it to understand your public key. Neither if somebody knows your public key, they cannot do with the computing power available, they cannot like kind of break the code to understand your private key. Because once somebody knows your private key, right, they have control over your account, they know how much money you have, and they can take out that money, right? So that's how it is a two-stage security part, right? And that here the algorithm is basically elliptic or digital signature algorithm. We'll not get into the how that algorithm works, right? Not into the technical details. Just for your kind of understanding that there is a separate algorithm which is used to encrypt this kind of from private key to public key, from public key to a Bitcoin address, right? This is the known as private and public key cryptography. So this also named as asymmetric cryptography. Why? Because you are creating different keys, right? In a symmetric cryptography, what happens? One key is there, right? So there is one lock. There will be two copies. One copy will be with me. One copy will be with, let's say, with you, right? Let's say that day we are discussing, right? Let's say my employee ID, that is a password, right? So that password is shared between me and let's say KIT University, and I want to send your exam paper documents, right? So I'll send a log box, right? And I'll send to KIT University administrative office or the exam department. That's key is shared, that password is shared. So with that password, right, they can open the log box and get into that contents, whatever the exam papers or whatever important documents, right? So that is symmetric cryptography, right? Symmetric means same shared key, right? Here it is different, right? From private key it is public key, from public key it is address, right? Nobody will know your private key. Public key and address will be visible. Bitcoin miners or the blockchain, any blockchain, whoever is working as miners or validators, right? So what they validate or what they verify is, they verify that, okay, this address belongs to this public key, right? So that part they will verify. Any doubt on this? So again, where I just discussed the transaction. Yeah.
Sir, if the person is transacting for the first time, then how the sender will get to know the Bitcoin address of the recipient's person?
How the
Will the recipient will send his address to the
address
sender?
is, yes, address is also publicly available. Yes. I should know your address to send that money to you.
Okay, sir.
Any other questions on this? So these are the basically advantages of why we are using the cryptography. Authentication, right? Association of public keys with specific accounts ensures that only individual with knowledge regarding author account's private key would create. So basically, each public key is kind of linked to one private key, right? So what does it mean? If I have the private key, then only I can authenticate. Then I can only sign it, right? Like I showed in that box, right? This log box can be opened with only this private key of this person, right? Because I have that money. That's why I have 1,000 rupees in my account and I want to send 100 rupees. So that log box of 100 rupees, I'll open. Now that transaction is, that box is open, and I'll put the Bitcoin address, this lock of the second person, and send it across. So when I am like signing it, so that process is known as signing, right? So Bitcoin miners know that, okay, this lock is opened by this person. That means this money has come from this person. This is authenticated, and this is going to the other person whose Bitcoin address is verified by the public key, right? So if you see, let's say transaction from A to B, right? What happens here? Age private key, right? So she is signing. So that or opening the lock process is known as the digital signature part, signing part, right? So she is signing it. Miner will verify because the public key is open. So miner will know the public key of A. So with that public key, that person, whoever is the miner, he or she, right? They'll verify that, okay, yes, this transaction is generated from person A, right? So person A opened or digitally signed, right? And the transaction is happening. Miner, because they do not know the private key of a person, okay? So but they know the public key, right? From public key, they'll verify the signature part, right? Then in this transaction box, I showed you that box, right? B's address is given, right? B's address is linked to B's public key, right? To the second person whom I send the money, right? That also should match, right? Because like I said, from private key, public key is generated, from public key, address is generated. So that should link, right? So these two parts basically miners verify it, right? That address is matching with the public key, and actually that person A is making that transaction, and miner cannot change anything in between, right? So here I cannot put rather than B's address, let's say the miner wants to put his own address or her own address. That part cannot be done, right? Once they do it, that transaction will get invalid, right? So digital signatures are able to achieve validity only event of zero modifications or tampering with associated data. In case of any tampering, like that day I was showing, and I'll show it again today. If I change anything, right, that transaction will get invalid, right? So that transaction will not get verified, right? And it will not get into any block. Identity management. So that part, the security part, the identity of a person A, B, or whichever person, you, me, whoever are there in that network, that is protected, because private key is only known to you, right? Unless I know the private key, I'll not know who is that person, right? Okay, let me show you that. So this part we did discuss last class, but again, I'm just trying to show you. So you will have a private key. Am I audible?
Yes, sir. Yes, sir.
Yes, sir.
You have a private key. From private key, that public key will be generated, right? So let's say I change this random private key, right? So just remember this first 3 or 4 digit, right? 045559, right? So when I go to the signature part, right? So this is my private key. What happens here? Let's say I send Piyush sends money to person B. Okay, let's say this is some cents. Let's say -1,000. This is my transaction. Okay, so what happens? This is my private key, right? What I'll do, I'll sign it, right? So this is the signature. This is the unlocking part. So what I'm telling, I'm authorizing it. I'm saying yes, I use have the hold over this account. I'm sending 1,000 rupees to person B, right? So this part is signed, right? So when the miner sees this message, right, that okay, somebody, obviously it will not be written Piyush or something, right? I'm just that's a person A. So what happens? This is the public key which is associated with the my person A's private key, right? So that part we showed here, right? My private key is 988,933 something this number, and public key starts with 04559, right? So what happens now? I am sending certain money to person B and I have signed it. Look, let me sign it. So this is my signature. What that miner, those third party miners, right? What they'll see, they will not see my private key. They know my so they will see my signature and they have access to my public key, right? So what they will verify here is whether this signature is belong to this public key. In this part you have to understand. They are not verifying that this signature is from this private key, right? Because private key is hidden, private key is secret, private key is only known to me. From private key, I have generated one public key, which is public, right? Which is known to all the miners. And from private key, I have generated my signature, right? Signature can be verified by the public key, right? Which is known to miners. So what they do, they'll try to verify it is green, right? Now what the miner, if they want to say, okay, rather than 1000, I'll do it is 10,000. Okay. They want to verify, it will not get verified. So they cannot modify here. They cannot change the person B to, let's say, person C or person D. That part cannot be done also. So this red means that transaction will not get verified. What did I change? Yes. So this is the signature part or the verification part from the miners. Any transactions they verify, right? So same thing again, $20 somebody is sending. So this is my address, right? Again, the address has come from my public key. Public key is from my private key. And I'm sending this rather than person A to B, right? So any Bitcoin or Ethereum, if you see the log of that, so there it will not be shown which person to which person, not from person A to person B. This is one address to another address. Then this is my private key. So I sign it. Okay. Miner will verify this signature belongs to my public key. So they'll verify it. So they cannot change this address, neither they can change this transaction. If they want to modify something rather than this address, let's say I put my somebody else's address. Okay, they want to verify, it will not get verified. So it has to be the same address the sender intended to send. Okay. Are you able to understand it, or is there any difficulty? Any doubt on this? So this is a single transaction, right? So in blockchain, what happens? Under each block, right? There will be number of transactions. At that moment, many people will be sending money to many other people, right? So number of transactions, okay, get inside one block, right? And that block again get hashed, right? See the number of security protocols there. So your transaction is safe, right? Your transaction is encrypted. Combination of transactions also getting into one block, that part is also encrypted, right? That part is verified and encrypted, right? So the level of security is kind of somebody getting into that and breaking the code and changing the transaction is kind of impossible. So here the miners who are working to verify the transactions and putting into block, they cannot modify the transactions, neither the monetary part nor the address part. They cannot do anything. Only part they can do is that whether the signature is belong to the person and the address belongs to the public key of the person that money is being sent, right? Those parts they verify. And obviously the other part is once the transactions get into block, they have to find a nonce, right? This number, random number they have to find, which will create a hash here with 4 zeros. I think in the Bitcoin it is 19 zeros. It should start with 19 zeros, right? So that is the cryptographic puzzle they are solving, right? So what is the work of a miner? First part is they verify the transaction. Each of the transactions they will verify, right? Number of transactions will get into a block, right? Once they get into a block, they have to verify or validate the block. So that verification or validation part is solving a puzzle. What is that puzzle? All this information, okay? All this information, including the block number, your nonce number ones, all the transactions, then there is something called timestamp. that point, what is the time, right? Then previous has, this has whatever the previous blocks has, right? Everything included, right? If I put a random number here and everything combined, I am encrypting it, right? So that has, right? So that encryption part, the whatever you put at the end, it will be 256 bits or 32 bytes number, alpha numeric number, right? So that part has to start with 4 zeros, right? Here, at least for the demo part, right? So that is the puzzle. So you have to put a number here such that, right, everything combined when this is encrypted, right? You have to find a number either manually or you have a like kind of clairvoyance, you know the future. So you just can know, or you create an algorithm which can find a that number very much quickly, right? So basically it is nothing but you are guessing, right? So when you talk about very difficult puzzle, it is not that the puzzle what you think of, right? It is basically puzzle of the computing power, how quickly you can guess. Because I can just start with 1 2 3 4 like that, and I will check that whether the hash is this 00408, right? So rather than 25205, 25205, right? Let's I put 56789, right? So hash is 452b, right? So this hash has to start with 4 zeros, right? So like that, I'll put many random numbers. So one way is to start with one, start with, so one is not working, 2, 3, like that. I'll keep doing this till I reach 25205. Once I reach that number, which is a random number once, right? So that is giving me a hash of 4 zeros. So whoever, like 1,000 miners will be working at a single moment of time. Whichever person is able to find that number first, right? They will say that, okay, yes, this block is verified. I was the first one to verify. And what they'll do, they'll send this random number to all the miners so that other miners also will verify. Will say that, yes, this random number is actually creating a, obviously with the combination of all the transactions, it's creating a block with 4 zeros, right? Then the, if 51% is, if there are 1,000 miners, if 500 miners or 510 miners agree that yes, this random number is correct and it is creating a hash of 4 zeros, right? Then that block will be created, and the miner who created or who validated, right? Right now in the Bitcoin, they'll get around 12.5 BTC, right? 12.5 Bitcoin. So that is their reward. That is the monetary reward they are working for. Otherwise, why will you put money in your computing power? Why will you invest in electricity? Like lot of money will get invested into infrastructure and electricity to run those machines, right? So that is the computer puzzle they are solving. They are just guessing a number, right? So that's why puzzle is a wrong word. It is just a guesswork, right? So how quickly you are guessing that number, which will create a hash with 4 zeros, right? In this case, like I said, in Bitcoin, actually it is 19 zeros. So the difficulty level changes every now and then, every 2 weeks. Is this part clear or any doubt? So transaction part is encrypted with asymmetric cryptography. Then all the transactions which get into a block, right? They also encrypted into a block through a SHA 256 algorithm, right? Secured hashing algorithm 256, right? So level of encryptions is too much to break. Yes, yes, Ankita.
Sir, in the nonce part, like we are searching for a number with 4 zeros in the hash
Yes.
in this model. So, sir, when we have to search for like 19 zeros, then the nonce part will also increase. Like it will not be a 5-digit number; it will be a bigger number.
Yes, so that nobody knows how that works, right? So whether it will be 5-digit, 10-digit, 12-digit, so that is the random number part, right? It can be a 3-digit also, right? So that part nobody knows how that nonce is. So that is the algorithm part takes care. So that random number which you'll put, so there is no linkage that, okay, if your hash is 19 zeros, it will be 18 digits or 20 digits or 5 digits. Nobody knows, right? So that is the randomness part. So you have to keep guessing and to find out this whatever 19 zeros, 7 zeros, 4 zeros, because the difficulty level keeps increasing, right? So to answer your question, if let's say this is 4 zeros, right? Whether there is a linkage of there will be 5 digit, 6 digit, 7 digit, I don't think there is any direct linkage. This number is random, right? It can be anything.
Okay, sir.
So peer A, peer B, whatever is written here, peer A, just imagine one miner. Let's say I am mining in Bitcoin. I am one miner. There will be another miner like you. There are here, let's say 3 miners, right? So 50% means if there are 3 miners, at least 2, when they agree that yes, this nonce is working, right? So they can go ahead and like kind of add that block to blockchain and go ahead with that, right? So that is the mining part, miner do. Transaction part, all the people who are working in the blockchain, right? If they're sending money to other persons, right? So they are doing those transactions. So that is the, when you discuss the node part, right? Some nodes just only for the transactions, some nodes which have full details, they do the verification and validation part. That is the mining part, right? Again, I have not discussed that. I'll discuss that today. If there are no questions, let's get back into the slides part.
Sir,
Yes, yes.
sir, if in a transaction we are changing anything, like if we change the message part or the public key or anything, sir, so how does the miner verify? Like in a block, we are using that nonce function, but here in case of transactions, how will they verify, like if anything has changed or not?
Anything is changed or not means?
So like in a transaction, if like for example, I write instead of 10,000, I change it to 20,000. So will the signature change or what will change that from that the miner will know that some changes have been made to the block?
Okay, you are telling if some modifications in the transactions are there, whether miners will know or not. Is that your question?
Yes, sir. How will they know that if there is any change or not, like during the verification? So because in block we use that nonce part that we will re-verify, and if the nonce, if the hash goes to 4 zeros, we know that this is the nonce. So, but in case of transaction, so like if any change is there, so does the signature change or anything else changes in the transaction by which we can know that this block has been tampered?
So that is that ECSDA algorithm will work on that. So that if any transaction part is changing or any, let's say addresses are changing, right? So that signature which is linked, that digital signature part, right, will get invalid.
Yes, sir.
So that part, that algorithm will take care. So that ECDSA, elliptical curve digital signature algorithm, that algorithm will take care of that. That if
Okay, sir.
somebody makes the transaction change or let's say the address change, right, that linkage won't happen. That linkage with the digital signature won't happen. So that part again, so when the miners do, they just run that algorithm and it will check. So they do not have to do anything additionally. But yes, so the mining part, mining power is very much required on this creating a block, right? Not much in the transaction part, because that algorithm is there, that algorithm will sort it out.
Thank you,
So
sir.
the most of the mining power or the processing power gets into the hashing the block. So that is the kind of race, or that is the fight for who will be able to get that nonce. Verification of transaction part, that ECDS algorithm takes care of that. The
So
miner
they will
just,
only run that algorithm.
yes, yes. So and they
Thank
can
you,
also,
sir.
they also cannot make any changes because they have authority there, right? So if I have that authority, I cannot change anything there also, because if I do, that algorithm itself will not allow me. So neither the miners nor the transaction nodes, none of nobody in that node, nobody in that blockchain can make any changes to the transaction. Once they do that, algorithm will make that transaction invalid. So that's why that miners just only run that algorithm to verify that. They They do not have to find any random number like they do it for the block. So these concepts, block part already we have discussed, but again, just to recap it, block is collection of transactions, right? And they have certain other data also. Like what was that data? Information of the previous block, right? The hash of the previous block. So block 0 hash, right? Block 0 is the first block, Genesis block. So the first block in any blockchain is known as the Genesis block. Genesis is the beginning of time, right? That is the Genesis. Block 0 timestamp at that point. So like I said, it is a append only timestamp block. That means anytime any block is getting created, at that moment, whatever the time is getting added to that, right? So whenever that encryption happens, that includes the timestamp also. Nonce, so that is the puzzle part. Somebody has to find that nonce, right? Find a random number which included with all the information will provide me a that has with 4 zeros, 5 zeros, or whatever the requirement, 10 zeros, right? So everything included, this all the information is included in the block, and the block is again encrypted, right? So whenever I jump into the next block, right, not all the information like this go to the block 2. What information goes? All this block, whatever information, 1 megabyte of information get compressed into this block 1 hash, right? So just imagine whatever information, 10 transactions, 100 transactions, everything inside this block is getting encrypted into this hash, right? One alpha numeric combination, right? 32 bytes or 256 bits. So in the block 2, only that code is going, right? Not all the transactions again getting listed into block 2, right? Otherwise, what will happen? The disk space will not be there by the time we reach 10,000 or 20,000 blocks, right? So that's why all the like information. So think about Genesis block, all the information in the first block, that at the end, think about in this way, your WinZip. What we like WinZip for those archive softwares. PDF file is 10 megabyte, 20 megabyte, 30 megabytes. We compress it and get into a single file, right? That might be 2 megabyte, 3 megabyte. Similarly, here what happens? All the information of transactions, timestamp, everything get encrypted into one number, right? So that is block 0 hash, right? So this is Genesis block 0. Similarly, all the information of first block gets into block 1 hash, right? So every information in block 1 at the end gets converted into one number alphanumeric code, right? So that is block 1 hash. Like that it progresses, right? So basically that's why the chain part comes, right? Because each block 2, when I'm talking about block 3, block n, block 2, so block 2 has all the information previous to that, right? Because block 2 has the hash of block 1. So block 1 has the hash every information of block 0, right? So that's why this is the blockchain part. Every block is linked to the, so every block is linked to the previous block and the next block, right? Any doubt on this?
So what is this Merkle root written here?
Yeah,
in
we
the
will come.
transaction?
Yes, we'll discuss that.
And sir, why that why in the Genesis block it is missing?
Genesis block, there is no transaction, only one transaction, right? So somebody creates a blockchain, right? So that is the first transaction. So in Genesis block, generally one transaction. So I'll discuss the Merkle tree, right? Genesis block. So Merkle tree is basically the combination of transactions. Sorry, not combination of transactions, combination of hashes, right? So again, that saves space, right? So what happens? Let's say in each block, 100 of transactions. Let's say not 100. Let's say 10 transactions, right? 10 transactions gets into one block. At the end, what happens? One block will be converted into one hash, right? So Merkle tree, what they do? So they combine all those transactions, right? So let's say there are 10 transactions or 20 transactions inside a block. So they combine all those transactions, two each, right? So what will happen? 20 transactions will get reduced to 10 transactions, right? 10 transactions into 5 transactions, 5 transactions into 3 transactions, 3 into 2, 2 into 1, right? So they combine all those transactions, right? So at the end, what they're trying to do, all those transactions will get combined. At the end, they'll provide you one simple number, right? So that is the part of Merkle tree. We'll discuss that. So to answer your question, why in Genesis block there is no Merkle tree or the reference of Merkle tree? Because that is the first block where somebody who created that blockchain, right? He will just make one single transaction to start the block, right? So that's why there is no need of Merkle tree here. So let me first discuss the Merkle tree, and then I'll come back to the noding part. Okay. So Merkle tree is something like this. So these are the transactions, right? So each transaction is hashed, right? Each transaction is encrypted. Hashing means the encryption part, right? So let's say I have 4 transactions. So for that particular block, I have 4 transactions, right? So these 2 transactions, 101 and 102, they got hashed, right? They got encrypted, right? So that will become transaction X, transaction hash 1, transaction hash 2, similarly hash 3 and hash 4. So what does Merkle 2, that data structure do, right? Hash 1 and hash 2 get combined and they create another hash 1, 2. Similarly, hash 3 and 4 combined, they get compressed to hash 3 and 4. Similarly, these two will get combined. At the end, that will be root Merkle tree code, right? So that will be the only hash which will get into the block. So rather than putting those 10 transactions or 1000 transactions or 100 transactions, we are again compressing it. So all those transactions also getting compressed, right? And that compression part or the way they are getting compressed is done by the Merkle tree. So Merkle tree stores all transactions in a block by, like, basically that digital fingerprint is nothing but the hashing part, right, of entire set of transactions. So what happens here? So let's say for the block 1, in my first block, there are only 4 transactions, right? So at the end, rather than writing all the details of 4 transactions, I have only one 32 byte or 256 bit code, which combines all the information of those 4 transactions, right? So all those transactions also are getting compressed. So that part again done by the Merkle tree data structure. Does it clarify your doubt?
Yes, sir.
At the end, there would be only one hash function for a particular block.
Yes. So all the transactions, let's say 10 transactions, because it is not mandatory that each block will have a same amount number of transactions. In one block, there might be 5 transactions. In another block, there might be 50. In another block, there might be 7 transactions. So for block 1, let's say I have only 7 transactions. So all those 7 transactions at the end will keep only one code, right? And that code will get into that block. Final version after all the verifications, right? Verification part has to happen first. After verification is done, all the transactions will get combined to one single hash, right? So that is known as the Merkle tree. So here is one interesting part. If you read the last part, right? So it is not necessary you have a even number of transactions, right? So here what happened? There are 4 transactions. So in the first stage, what happened? These 2 transactions got combined to one transaction, these 2 transactions to another transaction. So I have only 2 hashes. Then these 2 hashes get combined to create one hash, right? Hash, just imagine it as a alphanumeric code, right? So rather than a whatever, like 10 pages, 30 pages of document, if I convert that into a one code, right? So that is the hashing part, digital fingerprint, right? It is not necessary that every time in a block there will be only even number of transactions. Let's say there are 3 transactions or 5 transactions. Then how will Merkle tree work? So whatever the last transaction, let's say whatever the 5th transaction, they'll create a copy of that again. So transaction number 5, copy of transaction number of 5, that will be transaction number of 6, right? So why do they do that? Because this is a binary tree. So every time they need even number of nodes to compress. If there is odd number, they will not be able to compress. So here there will be 2, here they cannot compress 1, right? So that should be 2 transactions to compress. So whenever there are odd number of transactions, right, in a block, right, because there is no mandate that only when even number of transactions will happen, then only we will create a block. There is no mandate. there will be situation where there will be odd number of transactions in a block. So in that case, what happens? They create a copy of that last transaction to create. Let's say there is a 5 transaction, that 5th transactions will get copied, right? So when I say get copied, only the information part is copied. It is transaction is not getting repeated, right? So it is not that again 2 transactions, because the transaction is already verified. Now the only storing the data part is happening, right? So for storing the data, that transaction part, the transaction 5th is copied, right? It is not repeating it. It is just a data part is copying, so that I have 6 number of nodes. 6 will become 3. From 3 again I'll create 4. 4 will become 2. From 2 it will be 1, right? So that is how a Merkle tree works. Is this part clear or any doubt? So Merkle tree is basically, rather than storing all the transactions, record of all the transactions, all the transactions will get encrypted and will get you only one digit, one alphanumeric digit. So that is what Merkle trees works for. So in the Genesis block, right, because you don't have only have a single transactions, right? There is no need of a Merkle tree. So here if you see, there is no Merkle tree. In the transaction, in the block 1, let's say there are 6 transactions. Those 6 transactions will get into Merkle root 1, right? So all the transactions 6, 10, whatever, 5, 7, that will become only Merkle root 1. Similarly, here all the transactions will get to become Merkle root 2, right? So converting transaction to a single hash, the process is Merkle tree. Okay. Clear or any doubt? So now coming back to nodes, right? Nodes are nothing but the computers or the servers which are working on those blockchain network, right? So it can be a small laptop when the blockchain started 10 years back, right? Those work would have been done through a simple laptop which I am using or you are using. Right now, obviously, you need better servers. For transactions, yes, you can do transactions through your laptop or even through mobile phone. But for the mining part, you need a lot of computing power. You can do mining with your laptop also, right? But it will just waste of effort or time, because you will never be the first person to solve the puzzle, right? So it will just waste it. So you'll be trying to solve, but somebody else would have solved before you, right? So that's why you need that much computing power. It is not that you cannot do, right? But it will take a lot of hours, lot of time to solve or to guess that number, right? Guess that, so that solving that puzzle, right? So what are nodes? Nodes are basically electronic devices, laptops, mobile phones, servers, right? Which are basically have a IP address, identity, and obviously this is a peer-to-peer network, right? So there are 10,000, 20,000, 50,000 or 1 lakh nodes at any single moment of time, right? So what are the work they do? Processing the transactions. I am putting, so I am one node. From my laptop, the transaction is happening to another mobile phone, right? So those are the transaction part. Managing the transaction and their validity. So that is the validators or the miners, what they do. Storing the cryptographically linked blocks. So generally what happens? Those full nodes, right? So full nodes are the nodes which have copies of all the transactions, and so basically copy of all the blocks, right? Right now I think the latest block is around 65,400 something block, right? So that's what I was showing you. So all the information, all the block information will be available with those nodes, and obviously acting as a point of communication, right? Because that we discussed, right? Once I know the random number nonce, let's say I am a miner, I'll communicate that to all the other peers, all the miners, so that they also can verify, right? So full nodes and light nodes. So basically light nodes are somewhere, if you just want to transact, you just don't want to be the miner, right? You just want to use that Bitcoin, Ethereum or any other network to make certain transactions, right? So that will be your light node. Full node is all the information of blockchain is that with that you can verify, right? So that is the difference of full node and light node. Full node is all the information of blockchain is copied into your system, right? So that later you can use it for verification also, right? Light node, some part of the block, copy of the block will be kind of replicated or copied into your system, so that you can just run it for your transactions. Let's say I just want to send money, I do not want to play part on mining, right? Then I'll be a light node, right? Then there are other definitions, special nodes, lightning nodes, right? So when you get into the smart contract or decentralized app, right? So the problem with, at least in the Bitcoin or the initial Ethereum part, was, right, the transaction is very slow. Think it in this way. Generally in Bitcoin, every 10 minutes, again, so when I say 10 minutes, some blocks might be created in 20-25 minutes, some blocks might be created in 3 minutes, right? So average time they take is around 10 minutes, right? So every 10 minutes, one block is created, right? So generally in 1 hour, it is around 6 blocks, right? So what happens, it takes around 6 to like kind of 7 nodes, sorry, not nodes, 6 to 7 blocks in 1 hour, right? So it is very slow. Think about the electronic transactions which are happening, the UPI payments, Visa, MasterCard. In each second, how much transactions they are kind of handling, right? So in that sense, if I compare blockchain or the at least current technology of blockchain, till we have that consensus mechanism, we'll discuss later on, is very slow. The number of transactions which are getting processed in a blockchain is very slow, right? In comparison to Visa or MasterCard, if I just go and buy something through credit card, or let's say I want to send certain money to person B, I use Google Pay or let's say Phone Pay, right? Within few seconds, I can do that, right? But in blockchain, it will take certain time, at least 10 minutes to get into a block. And generally the trend is you have to wait for 6 blocks to know that yes, your transaction is valid and has gone through, right? So it is a lot of time. Customers have to wait also, right? If it is inside a like kind of country, right? So see the the opportunity and the challenge also. If I just want to send money within 2 minutes, let's say I took a Ola cab or a Uber cab, so nobody will wait 10 minutes, right? I just have to send that money. It need to happen within few seconds, right? But let's say, so that part UPI, Visa, MasterCard do much faster than the blockchain. But let's say I want to send money from my account to somebody in USA, Europe, right? Now the challenge happens, I cannot send a UPI from Google Pay or somewhere, or I cannot do a bank transaction. For bank transaction, that exchange rate will happen. It will take certain time, right? It is not that instantaneous. Maybe 1 day, maybe 1.5 days. Earlier, it used to take 2 to 3 days, right? There, if I compare blockchain, blockchain is faster because there is no boundary. There is no legal authority who will check that. What is this? Sorry, I think power went off. So there is no legal authority who is going to check that transactions, right? Those are the miners who are going to check, and it will happen within 1 hour, right? So the opportunity which is for the inter-border or the from different country to different country transaction, right? That will become very faster in a blockchain in comparison to traditional network of banking. But in a inside, let's say you are taking, or you went to a restaurant, you are ordering food, right? It will take certain time, right, to verify those transactions, right? So that's why verification part, at least in the Bitcoin, right, till now is very slow. 6 to 7 blocks in an hour is a very slow like kind of transaction settling in blockchain, right? So that is one of the biggest disadvantage as of now. And that's why we will discuss the other method, how like Ethereum or the other network are trying to like kind of speed or increase the number of transactions, right? In like in whatever the time limit is, right? Super nodes are basically something which sometimes there is a change in protocol, right? Recently, if you have read certain newspaper or kind of gone through certain blockchain articles, right? I think in next 2 to 3 months, Ethereum, the like kind of a competitor of Bitcoin, right? They are moving from one consensus mechanism to another consensus mechanism, right? Well, there is certain change in the algorithm, there is change on the mechanism how the blockchain works, right? So these are the nodes which are taking care of that. So those are the blockchain developers or Ethereum developers who are working in that part, the super nodes. So those are the nodes which have those kind of authority to change the protocols, right? Archival full nodes are basically keeping the copy of the, in case there is a failure later on, right? Some party is getting corrupted, right? Somebody hacked into like all the network and corrupted all the files, right? So these are kind of a backup servers, right? In case later on you want to go back, and actually it happened, right? Ethereum, I think back in 2017, right? Somebody hacked and I think they stole or they changed. So that's what I was telling you, right? It is not impossible, right? It has happened in the past where somebody has hacked into blockchain. So they hacked and they $50 million of worth of Ethereum got kind of. So somebody basically stole it, either somebody or a group of people, right? So when it was realized, right? So they came back and they went back to, they like kind of voided those transactions, right? They went back 3-4 blocks and went back to the previous, so that whoever has lost that kind of Ethereum or Ether or that money, right, was given back to them, right? So it is not impossible to hack into blockchain. People have done that earlier, right? So that's why a lot of discussion happened, and Ethereum, the current Ethereum platform which is working, right, is different from Ethereum Classic. Ethereum Classic is the old one, and Ethereum which is right now is working, that is the different platform. So archival full nodes, or they like kind of, not archival full nodes actually, the full nodes will be different type of, some are authority nodes who basically, so sometime let's say if I want to be part of that Bitcoin network or Ethereum network, right? Somebody will allow me that, provide me that access, right? So those are the authority nodes. There will be minor nodes, right? Minor nodes are the nodes who validate, verify the transactions and add into those blocks, right? Then master nodes are something maintains and validates transactions, but they do not add blocks, right? So there are certain master nodes who just only verify the transactions. They are not the miners. Miners and master nodes are different. Master nodes regularly get paid, right? Miners are somebody who, if they able to solve the puzzle, then only they'll get that 12.5 Bitcoin or whatever in Ethereum, that is in Ether transaction fee, right? So I hope at least most of you know, at least have heard about Bitcoin. I think almost all of you must have heard, but Ethereum, at least all of you are aware of, right? Ethereum is a competitor of Bitcoin, and the currency is Ether, right? If not, please read about that, because once we get into this technology part is over, right? Most of our focus will be something like Ethereum, right? Because like I said, we are not only talking about the cryptocurrency part, right? Ethereum platform is somewhere which you can create those smart contracts, which can be utilized for agriculture, healthcare, IoT, right? So we'll be much more interested in that part of the blockchain technology, right? But to start with, we started with this concept, which is common to all the platforms, blockchain platforms. But most of our post discussions, right, after session 6 or 7, right, will be much more focusing on Ethereum technology, right? Staking nodes, yes.
So the Ethereum Classic and Bitcoin, are they the same mechanism?
Mechanism in the sense, you are telling blockchain
When
technology?
you said, yes, sir.
No, they started with different technology. Technology means blockchain is the fundamental technology is same, right? But Ethereum is a platform where basically the what will tell, Bitcoin platform is only for the cryptocurrency part, transaction of Bitcoins, right? So you cannot do anything else. Ethereum started with the motive, right? Rather than only for monetary transactions, can other transactions also can happen. can we use this platform to raise just like crowdsourcing, right? What happens if you want to start a business? There is some concept of crowdfunding, right? You will ask money from different rather than your relatives, friend. You'll say that, okay, this is some business idea I want to work with. Whoever funds me, they will be a part of my company, right? Whenever my company like grows big, you will get certain shares, right? So that is the crowdfunding part, right? So it will be easier in Ethereum platform, right? Because now other people across world can look into and pay you in Ether, right? So the basic fundamental technology is same, but the idea of implementation, right, or the motive or the objective was different. Bitcoin started with just cryptocurrency, and still now also, and it will continue with that. Bitcoin, the block technology, right, or the blockchain platform on which Bitcoin works is only for monetary transaction. That is again in Bitcoin. But Ethereum started with the motive or objective that can this blockchain technology be utilized? Yes, monetary transaction has to be there, because without monetary transactions, why somebody will work, right? Apart from the monetary transactions, can I use it for verifications of insurance document? Can somebody use this Ethereum platform to like kind of crowdsource or crowd fund their project, right? So that is where the Ethereum started. Blockchain, so Bitcoin started only for monetary transaction, and it will continue like that. So that is a major difference between Ethereum objective and Bitcoin objective. Other coins which are starting, each of them have different objectives. There is something called VE coin, VE coin, BET. There is kind of Litecoin. So each of them have their own objective for how that should work, right? Cardano, so the coin is ADA, right? So they are a big competitor of Ethereum. So they both have same objective. So Bitcoin started with only objective of monetary transactions. Now whichever coins you see, right, cryptocurrencies or the platforms, right? So some of them are trying to use their platform to create supply chain technology. Some of them are trying to create that platform to get into insurance, decentralized finance, DeFi's, right? So all the objectives are different, right? And accordingly, those people who will be using that platform, let's say I want to like create something for, let's say like that day I was talking about, right? Organic farming, that labeling part, right? So I want to make that secure, right? So that certificate part need to come from blockchain, right? Rather than somebody like kind of tamper with it. That certificate will be tamper proof. Nobody can, once everybody knows from where that raw material came and where it was processed, everything will get into a blockchain and everything will get secure. Nobody can tamper with those kind of certificate or land records, right? So if I want to create certain applications, right, I cannot create those applications using Bitcoin platform, right? I have to either go for a Cardano or a Ethereum platform where they have those options of smart contracts, right? I have to write certain codes and I can create those smart contracts using that platform, right? So that is how Bitcoin and Ethereum or other platforms like Cardano differs. Monetary transactions in Cardano and Ethereum, apart from monetary transactions, obviously monetary transaction is the biggest element. Other kind of technology, other kind of use cases can be done, right? And that is where our focus will be, right? Financial transactions and non-financial use cases of blockchain. Was it clear?
Yes, sir.
Hashing in blockchain, again, we have discussed this. Hash is a fingerprint of data. It doesn't matter whether you have 10 line or 1 line or 1 complete movie, 10 complete movie, a library of books, right? Everything combined. So that is the importance of hashing. It doesn't depend on the size of the data. It doesn't depend upon the content of the data, right? No matter whatever data you give, it can be a song, it can be a movie, it can be a book, it can be just a single line of transaction, right? Everything will be hashed to that using that algorithm, right? it will be converted to a hash, which is a 256 bit or a 32 byte alphanumerical code, right? So this part hashing is a one-way conversion. So that means after encryption, I can only know that alphanumeric code, right? By knowing that alphanumeric code, I cannot know what that content is. What is the transaction? Is it a movie? Is it a song? Is it a confidential agreement, land record? I'll not able to know, right? So that's what I mean by hashing is one-way conversion. So again, different like SHA-256 is used in Bitcoin. KK-256 is based in Ethereum network, right? So different platforms, different blockchain networks will be using different kind of hashing algorithm, right? But at the end, the intent is same, right? So data is encrypted in such a way that it is a one way. So by knowing that code, I cannot come back and understand what are the content is, right? So I'm going a little faster because this part already we have discussed. I just like kind of given you this kind of some content so that you can read it out whenever you have time, right? In case of again any doubt, please let me know anytime you find any difficulty. So what are the advantages? Computationally efficient, that means, so it doesn't require many computational resources to compute or verify a hash. So what does it mean? Once you, let's say, announce that random number is created, right? Once somebody knows that, they can verify that, yes. So that part doesn't take much time. Finding the hash is, depending upon the difficulty, it can change. But once I know the random number, let's say this random number is creating that hash, right? So that part is not computationally difficult, right? Output of a hash will always be the same as long as the input is the same, right? So what does it mean? If I write my name Piyush or your name or a book, let's say there is a 600 pages book, right? I want to encrypt it into a single hash. Anytime I put that same book, it will give me same hash, right? But if I change a single line or a single word or the color of the page, right, the hash will change, right? As long as my input is same, it will ensure that I have that same hash output. If I change a single page, single digit, right? So that's why the number of transactions, see how many encryptions are happening. One part is changed, whole block get kind of cancelled or cannot be verified, right? It is impossible to convert the output of hash to input, right? That part we have discussed. If I have that image, right, pre-image resistant, that means by knowing that image, by knowing that output, I cannot convert into a input, right? I cannot know what input is. Collision resistant, that means it will not happen that two input will have same output. Let's say so that day you are asking something, right? In the beginning when you discussed, let's say I am Piyush, somebody else is Piyush. They are making the transactions of same $10,000 or $10 to another person B. That person is also sending to some another person. So like that, most of the variables are same, right? But there will be always certain other variable, that random number might be different, right? Time at which the transaction is happening is different, right? So all combined, like my hash, let's say I am person A sending to person B. Similarly, there is another person A sending to person B, same amount of money at same time, right? But there will be always certain other information which will be different, right? Maybe the block wherever I am working, the location where I'm working, the timestamp is different, right? Nonce will be obviously different, right? The random number which will create the hash with certain digits, right? So the what does it mean that even with the parameters, some parameters being same, it is very difficult to have two inputs giving the same output. Let's say, uh, so I want to like easily how to check your what else say, like let's say whether somebody is copying from another student. Like today I have given you certain assignment, right? Some of you will be smart and say that, okay, I'll not do that assignment, I'll not read about anything, just I'll copy others assignment, right? So what will happen if you just copied, if you just take that PDF and uploaded it, right, without changing anything, right? And if I has those two documents, right? It will give the same hash code rather than reading those two documents. What I'll do, I'll create a hash of, let's say, roll number 1 and roll number 2. Let's say 1 has copied from 2 or 2 has copied from 1, right? So what I'll do, I'll, without reading those two documents, if I just create a hash of first document and second document, if they're matching, that means it is a perfect copy of each other, right? But alternately, if the second person just have changed his roll number, right? Roll number, let's say whatever 20202001 to 2002, right? The hash will be different. All the content of the assignment will be same, right? But when I'm hashing, the two hashes will be different, only with the change of single digit, right? So that is the advantages or sometimes disadvantages of this algorithm. Is it clear? I think that day somebody was asking this question whether that will be same or not. There will be a situation where names are same, right? If same person is transacting to same another person, right? Any doubt on this? So hash rate is basically, hash means finding that number, right? Finding hash rate is that guessing, like every time you are creating a block, right? You are trying to find out that random number, which will create a hash with certain zeros, right? So you are basically, so puzzle is basically you are doing that guesswork, right? So hash rate means how many guesswork you are doing in a second or in a minute, right? So for that you need a lot of computing power, right? How fast you are, right? So if you see back in September 2019, China has around how much? Close to 75% of the kind of control. So when I say China, not as a government, so the like different miners who are working from China, like the IP belongs to the kind of country of China, right? So right now, I think after this, Chinese government has kind of put all lot of control. They like kind of banned all those mining and all those things. The control of China, the control of Chinese miners have come down. It is around 46%. United States is 16.85%. You will not find India here. Mining is not that much popular in India as of now, but a lot of money, lot of people have invested in cryptocurrency, right? So, like I said, you just can make transactions. You can own cryptocurrency without mining also, right? Mining is the part where you are generating cryptocurrency. It is one way to generate or gain cryptocurrency or the Bitcoin, Ethereum, right? Other way, you can buy it from market, right? Exchanges are there. You can just buy the Bitcoin or Ethereum, right? A lot of people have invested in cryptocurrency, but not into the mining part, right? It takes a lot of computing power, electricity, right? It won't be, I don't think in India it will be profitable to mine, at least with the electricity rate which have. So that's why if you see almost all the Eastern Europe part they do, because in those parts of the, let's say, Iran, where electricity is almost free, right? So that's why the kind of they have that kind of mining authority. Merkle tree we have discussed. Benefits of Merkle tree: integrity, validity, because all the transactions are getting combined. So going back, making changes to transactions is not possible, right? Once the transactions has happened, they are getting hashed, right? They are getting encrypted. Again, they are getting combined to other transactions, again getting encrypted, right? See, the number of encryptions are happening. So once that block is verified, somebody going back making changes to transaction is not possible, right? It helps in saving the memory and disk space. So that was one of the important reason, right? Otherwise, what happens if I'm storing 1,000 transactions, 10,000 transactions in each block? By the time it reaches 10,000 block or 1 lakh block, right? I won't have that much disk space, right, to store all the data, right? So in this way, what happens? All the data is getting into single digit, right? That code, right? So it will save you some space. And kind of sending, let's say you want to download that blockchain part, right? Rather than downloading 1,000 gigabytes of data, only 200 MB or 500 MB of data you have to download, right? So it is easier to, because right now it is easy to store, it is easy to transact over a network also, right? Just imagine if it is some terabytes of data, right? it will take a lot, even with very good network connection, right? It will take a lot of time to download it. Now, no matter how many blocks you have, right? Because it is just storing the hash data, right? The space required is small, and the sending over a network is also easy, right? Nonce we have discussed, right? Nonce is that number used once, right? That random number. Once I put it this or find that random number, which will validate that block, right? So let's say block 1 is created. Now we are moving into block 2. There are 3 nodes, 3 miners who are working, right? So they start to search for that nonce, which will create a hash, which will meet the hash requirement, right? So this person is able to find at 10 minutes, 14, 10, 14 minutes, 30 seconds, right? So he is able to find that nonce 7C4D DB31, which is giving this hash, right? So now what will happen? The other 2 nodes only will verify that yes, this nonce is creating this hash, right? And they will agree that yes, this nonce is correct. And now node 1 creates new block 2. So node 1 will say that okay, because I have I am the first one to find the random number, which is creating a hash with certain starting with certain zeros, right? And others have validated, verified it, right? Now he will create this node, sorry, create this block, and he will get a reward for it, right? Whatever 12.5 BTC or 6.25 BTC, whatever the current rate is, right? For creating a block, miners get rewarded, right? So just imagine, right? Right now, I think one Bitcoin is around 30 or 36 lakhs in Indian rupees. So if it is 6 Bitcoin, so you are getting around 3 crore or 2 crore rupees for creating one block, right? Obviously, right now this is the situation. 10 years back, it was, I think, few cents or few rupees max. So that is the like kind of challenge, right? You never know where to invest your time and effort in, right? 5 years or 10 years down the line, right now somebody will be working in a blockchain. None of us are aware of. 5 years or 10 years down the line, that will be the biggest technology in the world, right? And if some of us get into that technology as early as possible, by like most of you are right now 22 or 23, right? By you become 27 or 28, you will be billionaire or millionaire. But the challenge is knowing who is that and who is. So other ways too, you can, like, if you have the at least the good hold over those technology, right? You can create your own blockchain also. So this part I have already discussed. Miners are spending electricity in form of computational power in order to insert as many as random nonces as fast. So it is basically guesswork, right? So once you find a nonce which is meeting that hash requirement, that whatever here actually it is written 7 consecutive zeros. They are in the blockchain demo, it is 4 zeros, right? Whatever the blockchain requirement at that point of time, right? Leads to a hash output that starts with at least 7 zeros. So this is which is known as that difficulty, the difficulty of the puzzle, right? How many zeros it is starting with, whether it is 4 zeros, 5 zeros, 7 zeros, and it keeps changing, right? Because the idea is the like kind of puzzle will be difficult in such a way that every 10 minutes a block is being created. Average time to create a block is 10 minutes. If it is very difficult, just imagine none of the computers in the world is able to find that nonce. Then transactions which are included in the block will never get validated and will get entry into that block, right? So that automatically the algorithm makes sure that the difficulty of the puzzle. So what is that difficulty? Number of zeros that hash is starting with, right? So it is automatically every 2 weeks it changed, right? Why every 2 weeks? Around 2016 blocks. Every 2 weeks, if you see around in Bitcoin, every 10 minutes one block. So 1 hour 6 blocks. So every 2 weeks, if you calculate in that way, 2016 blocks. So every 2016 blocks, they'll check that what are the average time to create those blocks, 2016 blocks. If it is more than 10 minutes, they'll reduce the difficulty of the puzzle. If it is less than 10 minutes, the average time, let's say 7 minutes, right? Then they'll increase the difficulty level, right? So that is how the like kind of algorithm works. So we'll start with this from the next class. So we'll complete forking, and most of the next class we'll discuss on the consensus mechanism, right? So there is a class assignment from the consensus mechanism. Go through it. Complete it by, I think I have given till Sunday or Monday, right? So I want
Monday,
to, yeah. So it is your own understanding, right? So you can obviously the answers are there in the internet, right? You also know it, and I also know it that you'll go through internet. It is also there in my slide also, right? If you go through the last 2 slides, I have already explained it. What I want from you, what you understand by that Byzantine's generals problem, and what is your understanding of that consensus mechanism? How do they solve that problem, right? You can read as many as articles on internet, but try to write on your own words, right? So that's why keep it short within 1 page. Try to write. Otherwise, unless you write it on your own words, you'll not understand it, right? Copying, pasting from internet, it will take 2 minutes, right? You need not wait till Monday. Right now, also you can submit, right? So that day, I'm not going to ask you who copied, who did not copy. Neither you have time for that, nor I have time for that. What I want, at least spend even not 1 day, right? Spend 1 hour or half an hour. Go through that, what kind of consensus mechanism, what is that problem, Byzantine generals problem. It is not related to blockchain, it happened long back, right? And how that is related to blockchain, right? And how we're trying to solve that, right? So till then, take care, goodbye. We'll meet next class and we'll discuss on the consensus mechanism, right?
Excuse me, sir.
Yeah.
Sir, I missed my attendance.
Roll number.
343.
Okay. Anyone else? Roll number.
106.
Okay. Okay. Chalo, take care. We'll meet next.